Hello boys, how are you? Good morning. Today in chemistry, this is our topic. This is last topic. This chapter 4 reactions. A closer look at electrode reactions. Okay, upon your book page number 113, and we will discuss today this two page 113 to 114. Okay, now we will start. First of all, electrolysis of concentrated hydrochloric acid. Okay, when hydrochloric acid is electrolyzes, hydrogen form as a colorless gas at the cathode and chlorine as a pale green gas at the anode. Okay, why hydrogen at the cathode and chlorine at the anode? Because hydrogen form positive ion, and positive ion always move toward the cathode, and chlorine this form negative ion, and negative ion always move toward the anode because of this. Okay, this already we finished. Now here, oxidation and reduction during electrolysis. The reaction that take place at the electrodes during electrolysis involves the loss and gain of electrons. Negative ion always travel to the anode where they lose the electrons. Okay, the positive ion always travel toward the cathode where they gain the electrons. Okay, because positive cathode is negative and opposite charges attract to each other. And here next is during electrolysis what happened. The oxidation of non-metal ions always take place at anode. Okay, non-metal, because non-metal always they produce negative ions, and negative ion always move toward the anode and they take place at the anode. So the oxidation take place at anode in non-metals. The reduction of metal or hydrogen ions always take place at cathode, because cathode is negative terminal, and metals are and hydrogen always have positive ions. So it happen at cathode. This all things we have discussed already, and today we revise everything. The electrode, the rod that carry the current into and out of the solution are called electrode. Cathode, the negative electrode is called cathode, and anode is the positive electrode, that's called anode. During electrolysis, positive ion move toward the cathode and they are called cations. And during electrolysis, negative ions always move toward the anode and they are called anion. Okay. Next is the refining of copper by electrolysis. During electroplating, the oxidation process at the anode involves the metal anode actually dissolving. Metal atom lose electron and pass into solution as positive metal ions, and metal ions are discharged at the cathode as object become plated. Okay, because metal ions are positive and it and cathode is the negative, so the positive and negative they attract and they at the object they become plated. And then here how we purify the copper. Here copper here this is solution, and pure copper 100%, 99.99% copper here, deposit here, and impure, all impurities, they are left behind at the bottom, and impure copper, that is deposit here. Okay, this is a positive and this is negative. And copper, it make a positive ion, and that go to the cathode negative side, and it deposit here, and we take a copper from this side, and at the same time the impure copper, it is, you know move toward the positive side, because it is impure, not pure, and it deposit this side, and then we take pure copper from this electrode. Okay, this is how we separate the pure copper from different solutions that we take from the ore, from the ground. The copper used in electrical wiring must be very pure, 99.99%. Its conductivity maximum. The copper made by roasting its sulfide ore is in the air is about 99.5%, so it has an impurity level of 0.5%. This level of impurity cut down its electric conductivity significantly. Okay, if our copper that we use to make the wire, if it is pure, then it conduct the electricity maximum, otherwise it is. Okay, okay boy, this is our topic, and you revise this. Inshallah, see you later.